So in this video, we talk about the format of the instruction. So let's say if we have a system has a 16 register and 4 kilobyte memory. So basically we need 4 bit in order to access one of the register because 2 power 4 equals 16. And so we need a 12 bit for a memory address because 2 power 12 equal to um, 4096, so that's the 4 kilobyte memory. So if the system is to have a 16-bit instruction, we have a two choice for our instruction. The first choice is that we can use a 4-bit for the opcode, and also we have a 3 addresses. Okay, so address 1 have the 4-bit, address 2 have the 4-bit, and address 3 have the 4-bit. So this one basically just the represent the address of the register. Okay, because we have 2 power 4 gonna equal to 16, so we can using 4-bit to address one of the register. We also can use the 4-bit for the opcode and also the next 12-bit for the address. So in this way, the data gonna be accessed from the memory instead of loading to the register, and also perform the operation based on the value loaded onto the register. So the question is that why do we need to limit the opcode only to 4-bit? Is it possible to change the length of the opcode to different values, and also change the number of remaining bits that we can use to for the operand address? So basically, the expanding opcode can allow to doing that. So we can specify the opcode of 8-bit that require a 2-register operand, for example, or we could also allow opcode of 16 bits that operate on 1 register. So let's consider a specific example. Suppose we wish to encode the following instruction. We want to have a 15 instruction with 3 addresses, 14 instruction with 2 addresses, and 31 instruction with 1 addresses, and 16 instruction with a 0 addresses. Okay, so the question is that can we encode this instruction set in 16 bits? And the answer is yes. So how can we do that? So here the way we can do it by allowing the line of the opcode to vary, and we can create a very rich instruction set as the graphic represented on the right hand side here. So basically, we can see that use the escape opcode in the first group of 3 addresses instruction. So we can see right here when the escape code right here is at 1 1 1 1. So the first group right here you can see from 0 0 0 0 to 1 1 1 0. So that's the 15 3 addresses code. Okay, so each of the 4 bits right here represent the address of register 1, register 2, and register 3. Okay, so we have the 15 3 addresses address codes. And then we have the escape opcode, that's the 1 1 1 1. Okay, so it means when the first 4 bits are 1 1 1 1, that indicate that the instruction does not have 3 operands, but instead of have 2, 1, or none. This depends on the following group of 4 bits. Okay, so in the second group right here, you can see if the escape code is 1111, and the next group is gonna be a for the second group of 2 addresses instruction. The escape code gonna be a 1111 1110. Okay, so that's gonna be separate from the first group, second group right here. Okay, so in this second group right here, you can see that the number of code gonna be 14. That's from 0000 to 1101. So that's the 14 codes, and we have the 2 address code because this is the address for the register 1, and this address for the register 2. So that's the 2 address code. The for the third group of 1 address instruction, the escape code gonna be a the escape code gonna be a 1111, 1111, and 1111. Okay, so this the code gonna be from 000000 to 11110. So that's the 31 1 address code, where the R1 right here represent the address of register 1. And the last group that's gonna be from the 0000 to the 1111. So that's a 16 0 address code. So in this way, we don't have the address of the address of the register. So here the an example to see how the expanding code can be used to represent different instruction. So let's consider given a 8-bit instruction. Is this the question you want to ask is that possible to allow the following to be encoded: 3 instructions with 2 bit operands, 2 instructions with 1 4-bit operand, and 4 instructions with 1 3-bit operand. So the answer is yes, because we can compute with the first 3 instructions that require 3 times 2 power 3, that's a 3-bit operand. So we need a 192 bit for this first group. Similarly, we can compute for the second group, that's equal to 2 times with 2 power 4, that's a 4-bit operand. So we need a 32 bit to represent this instruction group. And the last one, we need a 4 instruction with the 3-bit operand. So that will require again a 32 bit for 3-bit operand. So totally, we add them up, we require a 256 bit in order to represent this instruction set. Basically 256 bits, so basically that's equal to 2 power 8. So that exactly with the number of bits available for us. So here the how we can use the expanding code to form just a instruction set. So the first group right here, we have the escape code that's gonna be 11. So the first group, we have the 3 instructions with 2 3-bit operands. Okay, so that's the first 3-bit operand, and there's the second 3-bit operand, and we have the 3 instructions right here. In the second group, we have the escape code gonna be 1110 or 1111. Okay, so in this case, we have the 2 escape code. In the second group, we have the 2 instructions right here with the 1 4-bit operand. So we have the 4-bit right here, that's the represent the operand, and we have the 2 instructions. In the last group right here, we have the 4 instructions with the 3-bit operand. Again, so here the 4 bits represent the 3 bits for the operand, and we have also 4 instructions for the this group. So you can see that with 8 bit we can represent a 3 instructions with 2-bit operand, 2 instructions with 1 4-bit operand, and 4 instructions with one 3-bit operand. Okay. Most of the computer instructions operate on data. However, there are some that do not. Computer manufacturers regularly group the instruction into the following categories: data movement, arithmetic, Boolean, bit manipulation, such as shift or rotate, input output transfer control, and some other special purpose. So the student can read more detailed information of the different instruction type for different category in the textbook, and you may can think of some example of each of the categories.